Our next speaker is Lilith Hafner, who will introduce Python.jl to seamless blend Python and Julia. Please join me in welcoming the speaker.
All right. Hello, hello. Today, I'll be showing you Python.jl, which is a seamless blend of Python and Julia, which you're going to realize you're going to want to seam. Let's see. Could we get a... Ooh, it's working. How delightful. OK, so this is a Julia REPL using Python. Isn't that great? What a lovely package name. And I can now use Python. So like I can do a for loop with Python syntax. That should work. And that println, that's a Julia function. Isn't this delightful? Mix and match. OK, but there's more. You can use, this is actually a superset of Python, this programming language. This like, once you say using Python, it's a superset of Python. So we can use classes. I'm not retyping this. So this class, for the folks who don't know Python, this is a class. It's an object. We've got an init function. We've got this self. You know how Python works. OK, I'm not explaining Python very well. And then this rand function. Rand is not a function in Python. That's the Julia function. So let's just define this class. And then let's make rn equals rand near 1,000. So what this class does is it returns, when you call gen of it, it will return a random number near that. So I can do like rn.gen float64. So that's going to be a random number near 1,000. Hey, look. And I can ask for an int 8. Huzzah. It's another random number near 1,000. So we're just like mixing and matching Python and Julia. Yeah. And the performance here is great. Gotta have good performance, or it wouldn't be a good mix and match. So let's say my range equals this times some, OK. You know, that's pretty quick. And then if we do a bigger one, I mean, Python performance, but oh, no, it's Julia performance. Great. Instant. Love that. Yeah, so it can do all the things. Time to first plot, if any of you have heard of that. Let's see. OK, it takes a bit. You know, pretty reasonable, solving time to first plot. And, oh, love that import as syntax. Hopefully we get that in Julia soon. Oh, and we still have Julia packages, of course, like grass. OK, we'll get back to this. And you can do cool stuff with Python, like, we need to, using Python, and then, like, I'm going to import web browser. I'm going to, it's just cool to be able to do all the Python things. I'm just launching my presentation right now. Give me a moment. OK. Adding a button. Like, I'm making a GUI in Python, because Julia needs better GUIs and better time to first X. That's why we make packages like this. Window.main loop? Yeah, there we go. And now here we have click me. I'll click that. Let's see if it's finished precompiling. Nope, not done. OK, let's do a presentation. There we go. OK. So Python.jl, hello, hello. These are the slides, QR code if you want them. Seamlessly blend, you will want to seam. OK, the demo, that already happened. What the? There's a bug. That's fine. That's not supposed to be in the slides. So Python.jl is a new front end for Python call that leans all the way into automagical. So there's this scale where over here is kind of like sane and reasonable, but also like everything has to be explicit. It's a little bit laborious. And over here is like kind of intuitive, automagical, does the thing without prompting, automatic conversions. And so PyCall is over here, and Python call, the successor of PyCall, is over here. And I take Python call, and I wrap it way over here. Gotta make everything automatic. Yeah. So this is great for demos and sales pitches. I could be telling y'all that this is the future of programming languages. It's not, but if I wanted to sell it, that's how I would do it. Magic is great for that. It's OK for like scripts. You can run scripts with this. It needs work for anything that's like shared, for packages, compatibility with the ecosystem. OK, a little side note here. The whole unreasonable effectiveness of multiple dispatch is based on people doing work behind the scenes to make sure things are compatible. It's not something that just happens. It's something that looks like it can just happen, which means people can do the work to make it just happen for the user, but you got to do compatibility with work by hand. Also, bugs and edge cases, like array indexing, is that 1-based or 0-based? Hard to know. Hopefully somebody will ask some good questions in Q&A. So how does this work? We've got a split runtime. When you call using Python, it launches a Python runtime. So now we've got a Python runtime and a Julia runtime, both present. So when then you give code to the REPL, it parses it. It tries to compile it in Python, because Python has a compiler. And if the compilation succeeds, then it runs it in Python. Otherwise, it runs it in Julia. That's great. That seems like a great option. Not going to hurt anything. And then globals are just automatically transferred. You set a global in Python, transfers to Julia. You set a global in Julia, transfers to Python. And so that's how we can, for example, have the Julia standard library in Python and the Python standard library in Julia. And this whole thing is less than 200 lines of code. I think it's 181, which is kind of cool that it's that easy to make something that looks so promising. So, So yes, it's a joke. I don't think people are going to be using this, should be using this for production code. Like, this is not Python call. This is not something that we can use in diffie-qpy. But also, it's not a joke that you can make a DSL that does really cool things very easily and very seamlessly in the REPL. And it's not a joke that the grass is still precompiling. Yeah. And for something less ambitious than a full programming language as a DSL, I think something like this is much more plausible to work out all the bugs from. So yeah, learning that Julia's incredibly hackable, that magic looks cool, but I mean, we haven't learned that it's hard to make robust. I'm counting on questions for this. I'm not going to show you it going wrong. Yeah. I saved a lot of time for questions. I have more. I can talk more if there aren't enough questions, but let's see. Yes.
So Python set syntax is curly braces, and their dict syntax is curly braces.
Yeah.
Julia's where clause is curly braces. How does that do?
Yeah. Well, let's see. So if you want to declare a dict, you could do something like dict equals, what is this Python syntax? Like x:3, y:7, 4? That's not that. OK. Cool. Oh, how do you do dicts?
Wrap your x in quotations, do y in quotations.
Cool, cool.
You're trying to define a symbol mapping to something, and Python doesn't support that.
Yeah, OK, great. So that works. And then for like where clauses, so like f of x colon t, where t equals.
Curly braces around the where, because that. Or where.
Where t, yes, great, great, great.
Yep.
Cool, so then f of dict should be a Python dict, right? Yeah, works fine.
But why isn't it parsing that t as a set?
Oh, well, because it's a where clause.
Oh no.
Next question, please.
Macros, question mark?
Yeah, macros work. Like the @time macro works, but we could do @threads. Yeah, let's do. Okay,
What about like code lowering for these mixed Julia Python things? What does it do with that?
Oh. What's this?
Capital T threads.
Sorry, live coding. Is it base.threads?
Oh, that's good.
Ooh. So it's using, so the problem here is that Julia and Python have range exported from their respective standard libraries, and it's kind of assuming that this is the Julia range. So I would have to say like something like that, and then it would work. And they're all in order because I'm in single-threaded mode. And you asked about code lowered?
Yeah, like what happens if you do that with some of this like mixed Julia Python syntax?
Yeah, so if I, like when this thing that was, so this is going real fast, so the code lowered has to be neat. Yeah, that seems like it works. Decorate? OK, I'm not good at Python. Sorry, how do we do, or? I heard decorators are a mess in the REPL, but maybe it's better here. Anyone confident enough in decorators to, like, let's skip that, because I don't know what a decorator is.
Two questions. Question one, how?
Aha!
Question two, why?
OK, so question one, how? That's a great question. And the answer is I'm still doing magic. Like, this is actually running live, but it parses either in Python or in Julia, depending on whether it can correctly parse in Python. So the real answer for how this where clause is correctly interpreted is this is not valid Python syntax. So it just parses it in Julia. And this is valid Python syntax, so it parses it in Python. And you can't actually mix syntax. It's the syntax of a REPL entry or a top-level statement in a file has to be homogeneous. So the syntax can't be blended, but because the global environments are blended, and so much of what a programming language is its standard libraries and namespaces, it can actually, it looks like there's a lot more blending than there actually is. The blending is just like pick which to interpret. Why? I think I was working on blending the languages in a more sensible way, and I thought, why not take this to the limit?
I have a kind of usage example. Okay, we have a team that develop AI models in Python, and we also need work in Julia, and I want to plot graphic things, and I need to extract the data from simulating. So I need a bridge in data frames. The data frame could be you fetch some data on the Python side, and then you use it on the Julia side.
Yeah, that seems, oh wait, you get the data on the Python side? You want to use Python for ML and Julia for plotting?
Well, I have to work with that.
OK, cool. Yeah, I mean, let's see if plots is, no, OK. So you're going to have to wait for pre-compilation. But yeah, I mean, if you want to deal with a system where like the REPL's just kind of guessing for you what language you're using at any given moment, that could work in principle. Like when I did this, that's passing a vector of float64 straight to a Python function. And that's all using Python call.jl plus a little bit of type piracy to make the conversions a little more magical. But that's like totally, yeah, you can totally transfer language. And you can also do that in a sane, sensible way with Python call. So yes, can do.
Thanks for this amazing vision. I was wondering, right now what you do is you try to parse it in Python, and if it doesn't work, you go to Julia. What I want to do is, if both parsings work, pick one randomly. And I'm wondering, what would be the most interesting consequence of that, in your opinion?
Oh, indexing.
Thank you. Two very distant questions. But the first one was, did you call a variable dict beforehand?
No. Yes. What? Oh, I did? Oh.
So that's a Python keyword.
Oh, that's fun. So like,
I love this.
dict is a Python keyword. How do we use that?
Yeah, you convert something to a dict.
How do we? Yeah, so the trouble here is that I assigned a variable to dict, which is something legal to do in Python, and maybe, let's see, let's get up a real Python. Yeah, and so then if I now call dict, I get that same error. So because I assigned to dict, it's not a keyword, actually. It's just a built-in.
Oh, okay. So I guess my question then is, how does it work with keywords in Julia versus Python?
Yeah, so it's the same like clever, the like clever auto parsing. If it's using Python keywords in a way that Python keywords aren't supposed to be used, then the Python compiler will fail, and then we'll use it in Julia. Whereas if you're using Julia's keywords like struct, Python. Yeah, so like this will correctly define a struct, and then I can make a of 4. And if you want, like, say, struct, I heard from Oscar struct equals 1, but we can just do struct equals a of 6. And then struct should be, yeah. You see, just a little mix and match. Yes, they're in the back.
Cool. Okay, you ready?
Got it. Unlike some exceptions, perhaps, but let's say I'm scared that I might accidentally type in the wrong language, and I want it to behave predictably. So would it be possible to add a feature where you disable the Julia parsing, so if the Python doesn't parse, it just errors out?
Yes. Yeah. Over there's a question.
What in the world is the What in the world is the type of a paren 6 that you've turned struct into? In Python, you could just call type on a thing.
Yeah, sure.
You just call type on that. What? Because that. Okay.
So what's going on here is that this is all just Python call with, it makes sense, great. Frames?
We do have a number of other interrupt libraries like rcall and several others. Can we do more? Can we keep going?
So yes, I think that the way that I would recommend I don't know if this is a good idea or not, but I think determining what language something is written in is a great task for a large language model. Maybe we could pass it to a large language model, because we got this suggestion to use a random number, and I think that's a good alternative. It's not a random number. It's very reliable. It's like 99% reliable, which is perfect for a programming language, because you need that kind of high reliability. And so I think that if you have a large set of programming languages, you could pass the source code if you can chunk it in some language agnostic way, and then pass each chunk to the large language model to dispatch to an appropriate runtime.
So are you proposing a Tower of Babel.jl? Just write once runs in whatever language it needed to?
Yeah, it would be, you could just use, it's not write once runs in whatever language, it's write many times run all in the same language.
So one further question, why has no one stopped you?
So I stopped myself. I haven't decided to register this in general because I'm concerned that people might take it a little too seriously. The last time somebody made a silly superset of Python, and like the last 10 times somebody's done that, it's been very well funded and a big waste of time, and I don't want this to be the next version of that.
So, can you define a Python class and do multiple dispatch on it?
Ooh, how can I pretend to do this on stage? I mean, with interface traits or some sort of way to dispatch on traits, yes.
That's cheating.
Yeah. So the tricky thing is all Python types are... Okay, yes, we can do this. So g of x int equals a, and then g of x, we'll just do, like we can dispatch on a Python int versus a Python object. That's not an int because the ints automatically convert. But if we have two different non-automatically converting Python classes, JuliaCon represents them both as
pi, I think.
Yeah, I think so. Yeah, so they're both pi's. All the things will be pi's. And so it would be possible. It would be, the options here would be either to make different Python types turn into different Julia types, which is kind of a problem because in Python, that would make all calls to Python type unstable. Because you know it returns a Python object, but you don't know what, because we can't run type inference through Python. And that's why Python call chose to make all things return pi. We could just automatically convert pi objects to like silly pi, or I don't know, like magic pi, with a type parameter that is maybe a string, a symbol that represents the Python class name, and then you do dynamic dispatch based on name with no name spacing. So it's possible. You could also do it more sensibly. I think there's a way of extracting a symbol representation of a Python type that is global unique. And so that would also be, then you could, yeah. So if you're willing to suffer all calls to Python being type unstable, then we can do that.
Thank you so much.
Could you actually make it, because Python has super type, right? So you could theoretically make pi any a subtype of any and then embed the Python class hierarchy in the Julia type hierarchy.
Yeah, and then we'd have to define new types on the fly when new Python classes are defined as part of the global variable transfer. Yeah, that could work. Then we'd have dynamic dispatch with subtyping. Yeah, and it'd be multiple dispatch, of course.
Does this mean I can finally use Python type annotations in my Julia code?
How do you do a Python type annotation?
That was the correct answer.
The correct answer is we already have comments.
But
oh, there's somebody up there. If you just shout it, I can call it back. So from the audience, great suggestion. Could you just have like a Python REPL mode, basically? Press a key to turn to Python, press a key to turn back to Julia. Yeah, you could totally do that. That would solve the whole switching modes based on guesswork issue. And then we'd just be left with Python call plus global variable transfer, and that merging the namespace, which I think could be workable. Yeah, also up there.
What happens if I want to call Julia code from threaded Python code and the GIL? Does that ruin everything? Or?
So the question is, what if you want to call Julia code from the threaded Python code with a global interpreter lock? I think that should probably be fine. I mean, that's a Python call question. If it works in Python call, then it works here. If the Julia functions are treated as external code, I think it could run asynchronously. But I don't know. That's a Python call question. All right, I think that's all the questions. And oh, yes, Frames.
How much type piracy?
Let's see. Definitely not any. So just like redefining the basic operations on Py. So it's not pirating base, it's just pirating Python call. Is that our time? OK.
We have time for one short question, if there's one more. OK. If there are no further questions, let's thank the speaker for a very interesting talk.